Okay, so F was 0, 1, 3, 4, 7, 8, 9, 11. Then G 1, 3, 8, 0, 11, 7, 4, 9. What was the question? Find G of F. C. G of F. So I've seen some correct answers there. So G of F, you start with 0. So we have G of F of 0. This is the same as G F of 0. So we have G. What is F of 0? F of 0 is 1. So we have G of 1. What is G of 1? G of 1 is 3. So we put 3 here. Then we go to G of F of 3. F of 3 is 4. So we do G of 4. G of 4 is 9. So we have 3, 9 here. And then 7 to 8, 8 to 0. And then 9 to 11, 11 to 7. And then you get the domain of G of F. This is 0, 3, 7, 9. Then you get the range of G of F. This is 3. So the range is 0, 3, 7, 9. So these are the same domain, same range. Then if you had to pick G of F inverse, you notice that the inverse is going to be 3, 0, 9, 3, 0, 7, and 7, 9. This is how you get the inverse. So if you get the domain of G of F inverse, we'll notice that what we have is 3, 9, 0, 7. And the range of G of F inverse, we'll notice that what we have is 0, 3, 7, 9. So they are still equal. So all the statements that we made before are still working here. So we can do another example. Another example. So we just call it D, where F will be 1, 3, 7, 8, 9, 10, 18, 2. And then G, the G is going to be -3, 1, -4, 7, and then -10, 9, and 0, 18. Then find 1 f of g, 2 the domain of f of g, and 3 the range of f of g, and 4 g of f if it exists. So let's see. What's the domain of, what's f of g? F of g, we start with g, -3, -4, -10, 0. So here we have g of -3, it will give us 1. Then we go to f, 1 is going to 3. So we'll have 3 here. G of -4 will give us 7. Then f7 is taken to 8. So we have 8, 10 to 9, 9 to 10. So we have 10, 0 to 18, 18 to 2. So we get to there. So when we come here, the domain is the one in blue, -3, -4, -10, 0. Then the range is one in red, 3, 8, 10, 2. And then g of f. G of f is supposed to start with 1, with 7, with 9, with 18. So let's fix now the gaps. So 1 goes to 3, and there's no 3 here in G. So we say G of f does not exist. Because it's supposed to be, when 1 goes to 3, then G must be moving 3 to some number. Now there is no 3 here. So that thing won't happen. Sometimes the examiner can make a mistake, but how do you get marks from that mistake? Because even the question that has an error, you may get 0. So you must show some reasoning. You first list all the domain set. And then when you check that there's no range, and you write G of f does not exist. So here you get 4 marks. But if you just look at it and don't write anything because the question has an error, you won't get any mark. You will get 0. Okay. So now we can leave this one and start talking about the domain and range of what type of functions? General functions. Now, 1, find the domain of A. F of x is equal to 3 over x minus 1. B, f of x is equal to x plus 3 over x minus 4. C, f of x is equal to the square root of 1 minus x. And d f of x is equal to the square root of 1 minus x over x over x plus 3. And then e f of x is equal to the root of x plus 1 over the square root of x minus 3. Solution for part 1. A, every time you are given a rational function, a function with whose denominator has x, your target is that the denominator must not be equal to 0. So for A, you pick x minus 1 and equate it to 0, and so for x. So we get that x is equal to 1. So we are saying the domain of f is x, a real number, such that x is not equal to 1. Why not equal to 1? Because if x is 1, then you have f of 1 is 3 over 1 minus 1, which is 3 over 0. This is undefined. So you want the function to be undefined. You don't want this. So we want the function to be defined. Okay. Then B, you, even if the numerator has x, we don't care about the numerator. We care about the denominator, which will make the function to be undefined. So again, you get x minus 4 equated to 0. So for x, so x is equal to 4. So the domain of f for B is x must be a real number such that this same x is not allowed to be 4. Because if it's allowed to be 4, the denominator will be 0 and defined. C, for C, the denominator is just 1, so we're okay with the denominator, but there's a root there. So we don't want this inside to be less than 0. We want it to be greater or at least equal to 0. When it is 0, the square root of 0 is 0, so that is defined. But if it is -2, the square root of -2 is a complex number, but these are real numbers. So we want it to be greater than or equal to 0. Then you solve for x. So you have -x is greater or equal to -1, divide by -1, divide by -1. So we get x is less or equal to +1. The rows of inequality, divide by negative or multiply by negative, the inequality will change. So we are saying the domain of f is x, a real number, such that x is less or equal to 1. That's the domain there. Then for D, we have the numerator. For the numerator, we have said x is here. X must be less or equal to 1. Then the denominator also. So here you get for the numerator and for the denominator. So far we are saying for the piece 1 minus x, x must be less or equal to 1. For the piece x plus 3, equate it to 0. So you find x is equal to -3. For this piece, x must not be equal to -3. So the domain of the whole function f is going to be x, a real number, 1, x less or equal to 1. But because -3 is found in this interval, we mentioned that x is not equal to -3. In other words, the domain of this function is the intersection of the two domains for the numerator and for the denominator. That is D, E. You said the numerator, x plus 1 should be greater or equal to 0. Okay, when does that happen? When x is greater or equal to -1. The denominator, x minus 3 should be greater than 0. For the denominator, it's not greater or equal to, because if we allow the equal to, it will be undefined at some point. So you say strictly greater, implying that x should be greater than 3. Then now you say, so if you look at the intervals, if I have this, the other one from -1. The other one from 3. So if I put it here, so you get the intersection. So say the domain of f is from 3 to infinity, like that one, which you can also write as set So now this function is not complete. It will also work when, because this guy can also be written as the root of x plus 1 over the root of x minus 3. So it will also work when x plus 1 is less than 0 and when x minus 3 is less than 0. Yes. So for this one, when x is less than -1, for the other one, when x is less than 3. Intersection again. So we have -1 from here going this side. And then we have 3 from here going this side. So for the -1, which is in the numerator, when it is less or equal to 0. So the intersection is this piece here. So we get again another domain of f to be -infinity up to -1. -1 included. So the final domain now, the domain of f becomes -infinity up to -1 union +3 up to +infinity. This guy is the final answer. After you realize that I can write this function in this form, then you get to see that, oh, okay, so I can actually put it, if both of them are negatives, then the fraction is going to be positive. So to be defined, Or if both of them are positive, then the fraction is going to be fine as well. Okay, then we talk about the range now. So we'll do another question based on the range. Example 2. Find the range. Find the range for A, f of x is equal to 3 over x minus 1 and c root of x plus 1 plus 2. And then d f of x is equal to x plus 2 over x minus 3. Then I also put e f of x is equal to root of x. So a is over x 1. X plus 1 y is equal to 3. Y is equal to 3 plus y divided by y. So x is equal to y. So the range of the function f is y, a real number, such. Get the function here because y is the so y is not equal to 0. In terms of y. Y in f of x. Because we say y equal to f of x. When we say y not equal to 0, we mean f of x. Let us stay in the range. Remember, the domain there can be anything. But the range, because the root, remember, if I give you an example of x squared is equal to 4, the solution that you get square root, so you have is equal to plus or minus the root of 4, which is plus minus plus 2. You get this one. So this one, you say, oh, okay, so for plus it was x root 4 or negative root 4. So if I just have a positive root 4, my answer is going to be positive 2. So because we have a positive here, if there's no sign, it means you have positive outside. It means that the range is going to be, the minimum you can get is 0. All other numbers will be positive. So that for E, the range is going to be, the maximum you can get is 0. All other numbers will be negative. So from inside. Again, the whole thing is the domain is the x minus